ShopBot desktop. This is the smaller version of what we have over there, the router. We use this mostly for wood and plastic compared to metal that we use lathes and mills for, because the spindle speed in this one and the one over there is about 12,000 RPM, which is pretty high speed for wood, finish cutting the wood and making a smooth surface. You could do the same thing with the mills, but it's not going to be as nice because the maximum speed, spindle speed for the mill is going to be like 5,000. So we use this machine for the woodworking. There are different projects here that were done with this machine. We can see that we can do a 3D art, which uses the ball nose drill. So it can go, you can see it has a round shape at the bottom, and it can do the 3D arts pretty well. Of course, the smaller your drill is, the better detail you can get. You can also see that from maybe a piece of wood like this, you can carve some boxes. For this reason, we use end mills to do that. You can see they have a flat surface at the bottom, and they go around, and in multiple passes they carve a surface. We call it a pocket, like a box. They also come with different sizes. If you have a huge surface area that you want to go down, you can use like a half-inch diameter. You can use smaller ones, and they come with different flutes. And down they are either down spiral or up spiral, or both. For making a coaster, that is going to be our main project this time, we will be using something called the V-carving tool. This is a 90-degree V-carve, as you can see, and it manages to make some fine detail for engraving on the surface of the wood, as you can see here. For our coaster project, we have already have a pile of different size wood stock. For our coasters, we're going to use a 3.5 by 3.5 inch squares, and as you can see, the grain of the wood should be the same when we put them should be horizontal when we put them inside our jig. We have created this jig so it can hold 3 coasters at a time. In order to fix the coasters in place, we are going to use this fixture. And we can hammer them down with dowel. And they're all fixed in place and they don't come out. In order to make the design for the coasters, we're going to use a program called Aspire. You can open that, create a new file, and the first page would ask you to put the dimension of your desktop ShopBot. We have already made handouts, and these handouts include every step for making the coaster, including the first page. As you can see here, you can just put the dimensions as you see it in the handout, and to make the coaster. You can see that we're gonna put the 24 and 18 here. This refers to the size of our ShopBot table. In our program, we're gonna put the 24 by 18 inch as the dimension of our whole board, and then we're gonna go and design each one of these squares and what we want to be carved inside each one of them. This point is the 0.00 point for the X and Y dimension on our ShopBot, and we will gonna have an offset from this 0 point to our first coaster, which is included in the handout. You can refer to it. So this is our 24 by 18 inch. That's gonna represent our ShopBot, as you can see here. This is the 0 point, 0 on top and 0. Yeah, this is our 0 point. Now we would like to design our 3 coasters. For that reason, we're gonna click on the square in the drawing section up here. We're gonna click on the square and we're gonna give it some dimension to where to position it. The anchor point would be on top, and we're gonna have 6.3557 and 7.6614 as the position offset for our first coaster. The size of the coaster would be 3.5 in the X direction and 3.45 in the Y direction. This dimension slightly changes on the Y direction if you're depending on the fact if you're using walnut or cherry for your coasters. For cherry it is 3.45 in the Y direction. For walnut it's gonna be 3.49 for the Y direction. You can press create and we're gonna have our first coaster.
Great.
Now in order to make 3 coasters, we can use a linear pattern. We can click on our square that we already have. Down here we can click on the create a linear array of copies, and we can tell it to create same dimension 1 row and 3 of them with selecting gap and putting 0 as a gap between them. So we copy it, and there we have our 3 coasters represented. Now we're gonna design only the first coaster using the same explanation that you see in this video. You can design the rest of the coasters yourself. First of all, because we don't want our tool to carve anything outside of this boundary, because it will touch our actual fixture, we're gonna make a offset boundary a little bit inside the coaster. You can go here, you can select our coaster, select our coaster, go to the offset, select offset, and inward we want to put 0.3 inches offset. As you can see, it has created an inner boundary for our coaster. Now, selecting the circle and coming to the middle of our coaster, we can see that our arrow changes to a bullseye. We can drag it out. The position of the center of our circle is already selected by the bullseye, and we can change the radius to what we want. For example, here we would like to use a 1.2 inches as our radius, and click apply. Now we have our circle. Now I want to show you how to use a circular pattern to create different objects. For example, in our case, a circle that follows this big circular pattern that we have in the middle. For this reason, we're going to use a circle. We're going to go on the top of our big circle in the middle. We can see that our arrow changes, and we're going to make a smaller circle. Give it a radius of 0.2. press apply, and close. Now by selecting the small circle, holding the shift key, and selecting the big circle, and coming to our drawing options down here, copy objects along vectors, we can tell it to follow our big circular pattern by selecting copy objects and selecting number of copies to be 6. However, we can also select the distance between the copies. In our case, this makes sure that we're going to have a range of smaller circles following each other in this pattern with 0.5 inches distance between them. And by clicking the force even spacing, we're going to have even spacing between them, as we can see here. And click close. You can click the small circle, shift click the circle to select the pattern. On our down here we can have an icon. We have an icon for copy objects. You can select copy objects.
Yeah, I already have this part. I just need to just say, simply say copy. Yeah.
And if you press copy,
great,
you can see that the circles follow the pattern. Close.
Okay. Yeah, very good. So next, you want to draw something inside the circle, right?
Mm-hmm.
Okay. And what are you going to do with the...
Is it recording?
Yeah.
Notice that we can zoom in and out of our design by the scroll key on our mouse. Now if we scroll in and select the big circle, because we only needed it for the pattern, if when it is selected, we can press the delete key on our keyboard to delete it. Also we can see that here, this is our first circle, and it has created 2 circles on top of each other. So we can click it, delete one of the versions, and then now we only have 1 copy of it. You can scroll it out again, and now we can put a text in the middle of our circular pattern here. For that, we go here and click on draw text. We can write our text here, maybe something like M-Shop. There are different variety of details. You can change the font, you can change it to bold, you can change it, align it different sizes, and change the size of your text. When you press apply, it is going to be written on this corner down here. Sometimes you're going to be looking for it. It's going to be down here. You can close, select your text. Using the arrow keys, you can move your text around. But if you want to make sure that it is centered in the middle of our coaster, you can click on it, shift click the inner border of our coaster, go here to transform objects, align selected object, and you can see we have a center here. By pressing that, this is going to be centered in the middle of our coaster. You can say close.
Yeah, it'll just we did the same before.
Okay.
Go back and show.
Awesome.
Yeah. Yeah, good. Great. That's good.
Yeah. Okay.
So you're down for the text?
No, because I want to change the size.
Yeah, that's what I'm saying, yeah.
So in order to change the size of the text, you can either double click on it, you can see this, and holding the shift key, you can go at the corner and change the size of the text to what you want. But in order to be more precise, you can press escape key, select your text, and again select the text, draw text icon. Here you can change the text height to what you want, for example 0.3, make it smaller, 0.4, and then you can press close, and again align it just like you did before in the center. Now that we are done with our design, we would like to create this coaster with our ShopBot machine. You can here click to switch to the toolpath tab. The drawing tab has been closed. You can always open it by pressing the drawing, you can see here. But now we're going to use the toolpath options for making our coaster. Notice that each one of these drawings that you have made until now are considered a vector. In order to select all of these circles together, you can left click and drag until all of them are selected. By pressing shift and clicking on the M shop, you can deselect M shop. Now if you press G on your keyboard, it will group all the circles together. So now if you click on one of them, all of them will be selected together. In order to ungroup them, you can press U. So U and G for grouping and ungrouping. Now we would like to select the inner boundary, the group of our circles, and M shop for our V-carve. Here under the toolpad, we can see the icon for V-carve or engraving toolpad. For this, we would like these dimensions to be exactly as here. We want our toolpath to start from 0 on the surface and go on a flat depth of 0.12. You can click and select a flat depth on here. Next thing we would like to choose is our tool. We are going to be using a half-inch 90-degree V-bit, 5-inch diameter, angle is 90 degree, depth of pass of 0.2, final pass step over of 0.01, clearance of 0.1, spindle speed 12,000 RPM, feed rate 2, gun range 5. Notice that sometimes this option changes from inches per second to inches per minute. Make sure that it is the unit is inches per second. Then press OK. And you can give your project a name. I call it Path 1. And you can select Calculate. Now what this does,
let's start from
oh, you want
yeah. Go back. Do that.
Okay.
Yeah. Good. Great. Thank you.
Now, what we did was that we selected 3 different enclosed vectors. So how the way this program works is that it carves, if you select only one vector, it will carve on the top of that vector. If you select more than one enclosed vector, it will engrave in the middle of those, as you can see here. In order to see how your final product will look like, you can select your toolpath, which we have only one here, and select preview all toolpaths or preview selected toolpath. This is going to be how our coaster will look like by the end.
Yeah, can I still go back and show the shop movie? Yeah, action. I think that's very fancy. Definitely should be close. Okay. Yeah. Great. Yeah. This is gonna be very good.
Yeah.
Yeah.
Awesome. So we can close it now. And okay. Let's go. So in order to save this toolpath, we close this. We select our toolpath. And here we have a save toolpath option. You would like to make sure that output all visible toolpaths to the file is selected. We can check if this is the correct toolpath, because sometimes you don't have only one path, you have multiple toolpaths, and you want to make sure that all of them are selected and put in one file. You select your machine. Our machine is a long list, and the desktop ShopBot is a arcs-inch.sbp. You'd like to select that, and you save your toolpath. Save it to your desktop rather than saving it on a thumb drive, because it can communicate faster with the ShopBot when reading the data. Notice that we can save our Aspire program, or we can save our toolpath. For right now, we only save the toolpath, but if you would like to reuse your program, you can also save your Aspire program from File and Save. Let's minimize this window. In order to communicate with the ShopBot, we use the ShopBot icon here, ShopBot program. This is the main window, and this is the control panel for the ShopBot. Here, this yellow icon is the easy and quick control panel to move the spindle.
Yeah. We're gonna do it twice. First, you click the button, and then because I don't really want to use that one. Right. So first, I check job where you click the button, and we're gonna do it again by. Right.
These four buttons will control the ShopBot in the X and Y direction. These two will control the height or the Z direction of the ShopBot. Now that we know how to move the spindle, you move the spindle so we have a space to work with our hands in order to put the tool in. For this project, we're going to use a 90-degree V-carving tool. We're going to put the collet, use the collet holder, put the tool inside, and then load it into our machine. And use these wrenches to put the tool in place. Goes before we save the toolpath. We can come here, as before we save it, we go here and material setup, it says set. Here, this is the thickness of our material. Our coasters are 0.375 inches, or 0.375 inches thick, and that is the number that we put as the thickness of our material. And we select the anchor to be on top, not at the bottom, and the anchor for our board to be down here. We want 0.2 clearance for the Z and 0.2 clearance for when it's plunging, and our home position we want it to be 0, 5 and 0.5. Okay. It asks us to recalculate our toolpath, so we're going to click, we're going to say recalculate, right click on it and say recalculate all, and then we can save our toolpath. Now we want to load our program, our toolpath that we saved, into the ShopBot program. You can do it by pressing File. I recommend that you use the second option, Part File Edit, to see your file before you run the program. We have saved it as Pass 1. This here. One thing that you can see is that our Aspire program made a toolpath file, which is basically a big file made of different coordinates for the ShopBot to move the spindle. You can see that all of them. The one important thing to notice is that the Z dimension is the minimum for the Z dimension is our minus 0.12, which we set in as a flat depth. We don't want it to go lower than that. So now that we look at it, everything looks good. You can close it and press cut part. Before we do this, every time you turn on the machine, you want to zero your X and Y, which is this icon over here, and it does it automatically.
Great.
Our X and Y is now 0. Press OK. Now, we also have to zero our Z axis. In order to do that, we use the plate here. We first move our spindle to the top of our coasters. That's where we wanted to Z it, using the control panel. Close it, and then the mechanism is that there's going to be a current from here to this plate. So we will lock this on our tool holder. We can notice that if by pressing this to the tip of the tool drill bit, there's gonna be a green icon over there showing that there is a current flowing through our plate, and that's what we want to check before we run the Z0. We hold the plate underneath, then we press Z. Ask us, say OK, and then you can see the message that says the Z axis is now 0. Put the plate back. In order to cut our coaster, press cut part, select our file. Notice that we can put offset for our work in two manners. We can do it inside the program, which that's what we did, or we can physically move the spindle, move the drill bit to the point that we want, and then select that as a 2D offset. But for now, since we have already put the offset in our program, this will be no offset. We're not going to change any of this. And we just press start. But before we press start, I have to tell you that space button or this button over here are your friends. If anything goes wrong by pressing the space bar or this button here, which will turn into stop after we press it, you can stop the machine at any time. You can also use this. You can also use this key here in case of emergency. Just press it down, and we will shut down the whole system. Let's start. We press start. As to turn on the router, say OK, and it will stop. Because it is a high-speed spindle, we always use the shield for protection.
Are you going to use for playing?
Also, there's a vacuum cylinder. By pressing this, you can turn it on. Connect the dot, and it clears the surface. So that's Spindle away.
Move to the. Just move it away.
Just move it away.
Yeah.
You can use your you can see there might be some of the wood chips still here. In that case, you can use a very soft material like this just to get rid of it and make it more smooth.